Most of the AI we deal with every day just kind of reacts to what's happening right now. But what if an AI could actually remember? What if it could learn from its past to build a sort of map of the world and then use that to make way smarter decisions? Well, that's exactly what we're diving into today, the huge leap from a purely reactive AI to one that actually has a memory. So let's start with a really practical question. Picture this. You're in a self-driving car. How does it really decide when to brake or when to speed up or change lanes? The answer to that question gets to the heart of a huge challenge in artificial intelligence, and it's basically the core of our whole explainer today. All right, first things first. We need to meet the most basic type of thinking machine out there, the simple reflex agent. Honestly, the best way to think about this guy is as the right now robot. Its entire world, its whole decision-making process is all about this very instant. And that's its defining feature, right there. This agent makes every single decision based only on what its sensors are telling it at this very second. There's no past, no memory, no context. It just sees something and it reacts. That's it. The whole process for this agent is incredibly direct. First, it senses the world. Let's say it sees the brake lights on the car ahead. Then, it just applies a rule that's been programmed into it. If the brake lights are on, then brake. And finally, it acts. It's a super fast, simple reflex. But as you can probably guess, that simplicity is also its greatest weakness. And that's the big problem, isn't it? Because the real world is messy. It's unpredictable. What if the car in front isn't just braking, but it's also swerving? Or what if braking really hard would cause the car behind you to crash? A simple if-then rule just falls apart when things get that complex. And that brings us to the next step in evolution, the model-based reflex agent. Now, this isn't just some small tweak, it is a fundamental upgrade. It brings in the one thing our simple agent was totally missing, an internal model of the world, which pretty much works as its memory. So this internal model is basically a knowledge base that it builds up from everything it's seen before. You can think of it just like our own memory. It stores all our experiences so we can build an understanding of how the world works and how things are likely to play out over time. So why is having this memory so critical? Well, it's because agents out there in the real world almost never have the full picture. They're constantly working with incomplete information. I mean, a self-driving car knows its own speed, for sure, but there's no way it can know the secret intentions of every single other driver on the road. And this right here highlights the core difference in the worlds they're designed for. A simple agent needs what we call a fully observable world, a place where it knows absolutely everything. But the model-based agent? It's built for the partially observable world that we all actually live in, where you have to make smart guesses based on incomplete data. Putting them side by side like this makes the difference totally clear. On one side, you have the simple agent, stuck in a perfect, fully known world, just reacting to the present with these rigid if-then rules. And on the other side, you have the model-based agent, navigating our messy, partially known world by using its internal model to combine what's happening now with everything it's learned in the past. Okay, let's make this real. A perfect example of this in action is Google's self-driving car project, Waymo. I mean, these cars are actually on the road right now in places like Arizona, and they depend completely on this model-based approach to handle complex traffic safely. So imagine this common driving scenario. The car right in front of you suddenly slams on its brakes. Now, a simple reflex agent might just do the same thing, slam on its own brakes, which could easily cause a big pileup behind it. But a model-based agent, well, it thinks about this very differently. Its brain goes through a much more sophisticated process. First, it updates its understanding of what's happening right now. Then, it checks its internal model, its memory of all the other times this has happened in traffic. It uses that model to predict what might happen if it takes different actions, like braking hard, or swerving, or changing lanes. And only then does it choose the best action to take. And this quote from our source material just nails it. The real power isn't in reacting instantly. It's in that tiny pause, maybe just a millisecond, to actually check your knowledge base and make an informed decision instead of just a pure reflex. Okay, but this brings up a really important question. What happens when the agent runs into a situation that's completely new, something that isn't in its memory at all? Does it just freeze? Nope, it learns. A lot like we do, actually. It takes in all this new information and it updates its internal model. That new experience gets stored, so if something similar ever happens in the future, the agent is way better prepared to handle it. In other words, it adapts. So let's zoom out for a second. Why is this upgrade from a simple reflex to a model-based agent such a huge deal? Well, it's all about getting AI out of those simple, predictable lab environments and into the complex, dynamic world that we all live in. This model-based approach gives the AI 5 huge advantages. First, it can finally work in the real, unpredictable world. It makes way smarter decisions because it uses context from its memory. It can actually predict the likely results of its actions before it does anything. It learns and adapts when it sees new things. And this is the big one. It moves way beyond the rigid limits of simple if-then logic. And all of this leaves us with a pretty deep question for the future. As these AI systems build more and more detailed memories of our world, how is our relationship with technology going to change? What does it really mean for us when the machines we build don't just act, but they also remember?